Hey everyone, today we're going to talk about the third isometry. If you remember, there's two categories of transformations. There's isometries and non-isometries. Isometries keep the shapes congruent, same size, same shape. Non-isometries create similar figures. They will be the same shape, but they will have a proportional size instead of the exact same size. We've talked about translations and reflections, and we've come up with those rules. Today we're going to talk about rotations, and there's 3 different types of rotations, so that's what we're going to be discovering today. Let's take a look at the first half of this page. I'd like you to please read the text there and see if you could figure out some of those blanks. Pause the video so you have think time and unpause when you're ready for me to talk about it. Okay, so hopefully you're ready. The first line is very important. It says, when we rotate, we always go in the order of the quadrants, unless we're told otherwise. So the standard for rotation is a counterclockwise rotation in this direction. So if you start at quadrant 1, you're kind of going to the left first. Maybe you start at quadrant 2 though, and you go like this. Regardless, we want to go counterclockwise and going in the order of the quadrants. A full rotation would be considered 360 degrees. So if you rotate halfway, that would be a 180 degree rotation. A 90 degree rotation is half of that. So that's a quarter of the way around. And it actually ends up meaning that you're just jumping one quadrant at a time counterclockwise. So if you started in quadrant 3 and you did a 90 degree rotation, remember, you have to go counterclockwise, so you're jumping one quadrant over. It's a quarter rotation. The next question, if you rotated a figure 90 degrees from quadrant 4, it would then be in quadrant 1. So quadrant 1 is the answer, and remember that we are assuming counterclockwise. They could always say rotate clockwise, but they'd have to specify it. If they don't specify it, we're assuming counterclockwise. How many degrees is in a 3/4 rotation? Well, if 1/4 is 90 degrees, multiply that by 3, that would be a 270 degree rotation. So the 3 rotations we often talk about then would be 90 degrees, 180 degrees, and 270 degrees. We don't really talk about 360 degrees because that's just going back to where you started. That's the same as rotating 0 degrees. So we usually talk about those 3. Let's take a look at the next activity. Pause the video, see if you can finish up the page. Unpause when you're ready for me to talk about it. So the question says the red heart is beginning at 0 degrees. And 0 degrees we could have chosen anywhere in the circle. We could have even put the heart here and said that this was 0 degrees. It's just a random place on the circle that the heart is at. How many degrees, of course, counterclockwise, would the red heart have to rotate to get to the yellow heart? That would be jumping one quadrant. So counterclockwise, that would be 90 degrees. Then they ask about the blue heart and then the green heart. So if we go another 90 degrees, because each one of these is 90, we'd get 180 degrees here. If we go another 90 degrees, we would be at 270 degrees. And then they don't ask about this, but to get back to the red heart, another 90 degrees, we'd actually be at 360 degrees. So 360 degrees and 0 degrees are in the same spot. Then they ask us to repeat the same activity, but going clockwise instead of counterclockwise. So I'm going to switch to blue so it stands out. I'm going to erase all this extra stuff. So if we're rotating clockwise, we're going in this direction now. And that would make this 90 degrees clockwise. Another 90 degrees would get me to 180. And another 90 degrees would get me to 270. And they don't ask for this, but if I did do one more, I would be back at 360. What do you notice? So you might have put down a bunch of different things, but what I notice, and these are really the most important things that they're going to be talking about, is that 0 is the same thing as 360, no matter which direction you're going. And 180 degrees in either direction is the same as well. What's different is 90 degrees and 120 and 270 degrees. Those kind of flip. So 90 degrees counterclockwise is the same as 270 degrees clockwise and vice versa. So that's something to keep in mind. Yeah, I think those are the main points of what they wanted us to see here. Now we're going to go through each of the 3 rotations that I told you about. The first rotation we're going to discuss is a 90-degree rotation. So remember, that means we're assuming counterclockwise. It's the same as a 270-degree rotation clockwise. So if they gave me a problem and they said, rotate this 270 degrees clockwise, I know that they really mean 90-degree rotation because we always think about counterclockwise. Let's take a look at the picture. So the starting image could be anywhere on the graph. And what a 90-degree rotation means is that you have this right angle. You would not draw this every time. This is just to show you what it means. You have this right angle, and then for each one of the points, so if I take point A, for example, and I draw a line from point A to the origin, and then make a 90-degree angle, it is rotated to the other side of the angle. That's what a 90-degree rotation means. And then you could redraw that same 90-degree angle for each of the other points. So like for B, the 90-degree angle would probably look like this. That's probably 90 degrees. And so it'd be the same thing for all the other points as well. That's complicated though. We would not be drawing 90-degree angles over and over on the graph. There's tricks and shortcuts for us to do this. So what it says is quadrilateral ABCD is located at, and then they give us a point for each of these. They've rotated it 90 degrees about the origin. That means the origin is like the center of our rotation. Can you please write down the coordinates for A prime, B prime, C prime, and D prime? Pause the video so you can take your time on that. Okay, so let's see what I got. So it looks to me like A prime is at -7, 3. B prime looks to me to be at -5, 7. C prime looks to be at -2, 5. And D prime looks to be at -4, 3. Hopefully I didn't mess up. Hopefully you got all the same answers. Now here's where we're going to figure out a trick. Look closely at the original figure's coordinates and the image's coordinates. What rule or what pattern can you figure out? So basically if I look at A over here and I look at A prime over here, how could you go directly to the answer without graphing it? And then see if your rule applies to the other 3 points as well. Pause the video, take a second to think about it. Okay, here's what I noticed. I noticed right away that the first coordinate in the pre-image became the second coordinate. So like for point A, the 3 was originally my X value. Now it's my Y value. And that's the same for B, C, and D. The other thing I noticed is that my Y coordinate from my pre-image moved to my X coordinate, but became the opposite. So 7 moved to X, but it became the opposite. Instead of 7, it's -7. And that's the same for all the other points as well. So if they give you a point and you know the X and Y value, you know you have to flip them, and then you have to make the Y value the opposite. That's how you would actually find these answers. You wouldn't necessarily be measuring 90 degrees on a graph. Okay, so that's 90 degrees. See if you can repeat the exercise with 180 degrees. Pause the video, unpause when you're ready to come back. All right, hopefully you are ready to go over this. So the first thing that I did was I wrote down the new coordinates for A prime, B prime, C prime, and D prime. Looking at the graph, I found that A prime was at -3, -7. B prime was at -7, -5. C prime was at -5, -2. And D prime was at -3, -4. So 180 degrees. And I'm going to draw the arrow going the other way because their arrow is clockwise. I want counterclockwise. It's like going 2 quadrants. And you can see that they've drawn a line from A to the origin, and then they've kept going because we want 180 degrees. That's a straight line. So that's how they got the next point A. All right, so now looking at the rules, I can see that the X and the Y value both stayed in the same spot, but they both became the opposite. So 3 stayed in the X position, but it became -3. 7 stayed in the Y position, but it became -7. And that was true for all 4 of the points. So that's the rule for a 180 degree rotation. Last one we're going to talk about is a 270 degree rotation. So this is a 270 degree rotation counterclockwise. But if they asked us to find a 90 degree clockwise rotation, we would know we would have to convert it to counterclockwise. So the way that this would work is it really almost starts with a 90 degree angle, but then you rotate 3 quadrants on the outside of that angle to get to the new points. All right, so pause the video, complete this activity, unpause when you're ready for me to talk about it. All right, so I found that A was at 7, -3. B was at 5, -7. C was at 2, -5. And D was at 4, -3. For the rule, I see that the old Y value moved into the X position. So 7 moved to the X position. And that is true for all 4 points. I see that the old X value moved into the Y position, but also became the opposite. So 3 became -3 in the Y position. So the rule is Y -X. Switch the 2 points, make the X negative. Or not necessarily negative, but the opposite. So to fill in the summary chart, because this summary chart we're going to keep referring back to throughout the next several days of practice, if we're doing a 90 degree rotation, that's the same as 270 degrees counterclockwise. 270 degrees clockwise. So we always like counterclockwise, but if the question asks for 270 degrees clockwise, we know they really mean do a 90 degree rotation. We have to convert it. And the rule for that one was -YX. That means flip X and Y, take the opposite of Y. 180 degrees counterclockwise is the same as 180 degrees clockwise. The rule for that is keep X and Y in the same position, but take the opposite of both of them. Lastly, 270 degrees counterclockwise is the same as 90 degrees clockwise. And the rule for that is flip X and Y and take the opposite of X. So this little chart's going to be really helpful going forward. And in fact, what I'm going to do right now is put that into the chart that we've been keeping. So we have it for next time. These are, okay, that didn't paste the way I